Smart Culture, Mathematics.
Let's take a look at the following investigation. So what we'll do is we'll plot a sine graph. So we have to plot the following function. F of theta is equal to the sine of theta, where theta takes on values between 0 degrees and 360 degrees. So we'll use our calculators to complete this table, and then we'll use this table to plot the values of theta on the x-axis and of sine of theta on the y-axis. Remember to round your answers to 2 decimal places. So let's take our calculators and start substituting the values for theta. So the first answer will be equal to 0. Sine of 30 degrees is equal to 0.5. Sine of 60 degrees is equal to 0.87. Sine of 90 degrees is equal to 1. Sine of 120 degrees is equal to 0.87. Sine of 150 degrees is equal to 0.5. So we have to complete this entire table. The next thing that we'll do is we'll plot the points. So let's plot the first point and the second one and the third one and the fourth one, and then you can plot the rest of the points as well. And then we join all these points with a smooth curve. Take a look at the wave shape of the graph. Each complete wave takes 360 degrees to complete, and this is called the period. The height of the wave above and below the x-axis is called the graph's amplitude. You can see that the maximum value of y is equal to the sine of theta is 1, and the minimum value is -1. So in this case, the domain will be the set of all angle measures in degrees from 0 degrees inclusive to 360 degrees inclusive. So this means the function includes all real number angle measures starting at 0 degrees through to and including 360 degrees, which completes a full circle. The range is -1 and 1, so this indicates the maximum and minimum values that the sine function can reach. The sine of any angle cannot exceed 1 or be less than -1, reflecting the fact that the sine function represents the y-coordinate of a point on the unit circle, and thus it must lie within the interval -1 and 1. Let's take a look at the x-intercepts. So the x-intercepts listed are at 0 degrees and 0, 180 degrees and 0, and 360 degrees and 0. So these points indicate where the graph of the sine function crosses the x-axis, which occurs when the sine of an angle is 0. Let's take a look at the y-intercept. So the y-intercept is given as 0 degrees and 0. This is where the graph crosses the y-axis. For the sine function, this occurs where theta is equal to 0 degrees. Let's take a look at the maximum turning point. So the maximum turning point is at 90 degrees and 1. This is the peak of the sine wave, where the value of the sine function is at its maximum. Let's take a look at the minimum turning point. This is at 270 degrees and -1. So this is the lowest point of the sine wave, where the value of the sine function is at its minimum. Let's take a look at this example question. We are asked to sketch the graph of this trigonometric function. So we have to sketch the sine function that has been modified with a coefficient and a vertical shift. You will see that the function is f of theta is equal to 2 sine of theta plus 3, and it's defined for theta in the closed interval 0 degrees and 360 degrees. So we are given the domain of the function, and it specifies the interval of theta for which the function is defined. So theta belongs to the closed interval from 0 degrees to 360 degrees. From the equation, we can see that A is larger or greater than 1. So the graph is stretched vertically. We can also see that Q is greater than 0. So that means the graph is shifted vertically upwards by 3 units. So what we'll do now is we'll use our calculators to complete the following table. And then we'll plot all these points. And then we'll join them with a smooth curve. The graph shows one complete cycle of the sine wave, modified by the coefficient and the vertical shift. The coefficient 2 amplifies the sine wave, doubling its amplitude, which means the distance from the midline of the graph, which is at y is equal to 3, to its maximum and minimum points is 2. This results in the graph reaching up to y is equal to 5 at the maximum points and down to y is equal to 1 at the minimum points within one cycle from 0 degrees to 360 degrees. The vertical shift of positive 3 raises the entire sine curve so that the midline is no longer at the x-axis, but at y is equal to 3. So this means the sine function never touches the x-axis, and its maximum and minimum are no longer at y is equal to 1 and y is equal to negative 1, but shifted accordingly by the value of 3 units up.
And that's a wrap on today's fascinating journey through the world of knowledge. Don't forget to hit that subscribe button and join our ever-growing community of curious minds. We can't wait to embark on new educational adventures together.